All right, so this discussion will be over reduction of air pollutants. So our methods of reducing air pollutants. Overall, the goal is to reduce the amount of emissions that we're putting out into the atmosphere, which will therefore reduce the air pollutants that are in the atmosphere. We can do this 3 ways. So we have regulatory practices that we put into play, conservation practices, as well as using alternative fuel sources. So the Clean Air Act and these things called pollution credits are going to be some of our regulatory practices. So the Clean Air Act set deadlines for reducing air pollution to acceptable levels, and we know that it targets 6 air pollutants. And then we have these things called pollution credits, which is kind of a bizarre concept. So companies that are able to reduce their emissions well below EPA set standards earn what's called pollution credits. They can then go sell those credits to companies that release more than the levels that the EPA has set. So in practice, they effectively offset each other. So the companies that have produced below the standard can sell to companies that produce above the standards, and effectively the emissions are canceling each other out for the most part, but one company is profiting off of having below EPA set levels of air pollutants being emitted. We also have CAFE vehicle standards, which are corporate average fuel economy standards. They require the entire U.S. fleet of vehicles to meet certain average fuel, and I believe that's fuel consumption, requires vehicle manufacturers to work to make more efficient vehicles. More efficient vehicles burn less gasoline and release less nitrous oxides, particulate matter, carbon monoxide, and carbon dioxides. Some methods for preventing air pollution. So we have e-check for our automobiles. This is kind of being phased out for our newer cars because they're naturally going to meet the requirements of an e-check. But for older vehicles, you'll go get your car checked every other year for emissions. So if your car is made in an even year, typically you're checking your car every even year, and then odd years as well. And we'll check on odd years. So what they're checking for is sulfur emissions, essentially, and they're also checking for, I believe it's carbon monoxide as well. So they're checking for a couple of different air pollutants when they do your e-check. It's just to make sure that your exhaust isn't putting a high level of harmful emissions into the atmosphere. We also put vapor recovery nozzles on our pumps at gas stations. So that would be the nozzle itself, but also these shields that went into it. So what this does is it prevents fumes from escaping into the atmosphere when fueling a motor vehicle. So there's going to be gases or vapors, I should say, that are contained in both your gas tank as well as the tank holding the gas below ground at a gas station. What the vapor recovery nozzle does is it allows kind of a two-way flow for those vapors as well as the petrol to go in and out of the gas pump to your car and vice versa. So by doing that, it prevents the vapors from releasing into the atmosphere. In 1975, we put catalytic converters in cars. What this does is it converts pollutants in exhaust to less harmful molecules. It helps to reduce carbon monoxide and nitrous oxide. It was one of the main reasons that lead was removed from gasoline because it was super damaging to catalytic converters. So all of our gas now is going to be unleaded gasoline. And this is just what a catalytic converter looks like and what it does. So to control emissions, this is specifically for industry, mostly coal burning factories. And we can use desulfurization, scrubbers, baghouse filters, and electrostatic precipitators. And I'll point out which ones AP College Board is particular about. We've talked about limestone, which is calcium carbonate, and how it is able to buffer soils from acid rain. We can also use crushed limestone, which is not SO2. SO2 is what we're trying to reduce with the crushed limestone. But this can be used to reduce the amount of sulfur dioxides that are being put into the atmosphere. The calcium carbonate or the limestone combines with the SO2 to produce calcium sulfate, thus reducing the amount of sulfur dioxide that's going into the atmosphere. And then that calcium sulfate can be upcycled, or recycled, I should say, into like a gypsum wallboard or sheetrock for home foundations. We can also reduce NOx, or nitrous oxide pollution, by using fluidized bed combustion. So these jets of air are pumped into a combustion bed. They bring in more oxygen to the reaction, so they make combustion more efficient, bringing the sulfur dioxide into more contact with the calcium carbonate in the limestone. And this also allows coal to be combusted at a lower temp, which emits less nitrogen oxide. Fluidized bed combustion is not that common as far as the AP test is concerned. The other one, the crushed limestone, that one I've seen here or there. It's the other ones coming up that are particular that College Board wants you to know. So scrubbers, you have wet scrubbers and dry scrubbers. So these are attached to the power plants or the factories themselves. So they remove particulates and or gases from industrial exhaust streams. And I'm not going to get into the whole process. You can read that step-by-step process on your own. So wet scrubbers may involve chemical agents that absorb or neutralize NOx, SOx, and VOCs, but also include mist nozzles that help trap particulate matter and water droplets as well. The mist droplets with pollutants and particulate matter are trapped, and then they fall to the bottom of the scrubber, or they get trapped at the top by a mist eliminator, which is this kind of shield up here towards the top of the scrubber. The sludge collection system traps polluted water for disposal. So that water does need to get treated and disposed of, but it is reducing the amount of particulate matters as well as your NOx, SOx, and VOCs that are going into the environment. Dry scrubbers work very similarly, except there is no mist in the scrubber itself. So these are just large tubes filled with chemicals that absorb or neutralize the NOx, SOx, or VOCs. Calcium oxide is a common dry scrubber additive which reacts with SO2 to form calcium sulfite. So these are just kind of the differences. Again, the wet scrubber uses water spray or mist, whereas the dry scrubber does not. And then we'll get into electrostatic precipitators here in a second. So an electrostatic precipitator passes emissions through a device with a negatively charged electrode, which gives the particles a negative charge. The negatively charged particles will stick to positively charged collection plates, effectively trapping them. The plates are discharged occasionally, so particles fall down into collection hopper for disposal in landfills. So essentially you have particles that receive a negative charge, they pass over positively charged plates, so opposites attract. So like a magnet, those particles will then be stuck to the collection plate, and then the plates are discharged, so the particles fall into like a container, I guess, for disposal in landfills. So these would be your collection plates that have your positive charge, and then eventually when they are discharged, the particulate matter kind of just falls to the bottom here. Baghouse filters, think of these kind of, most of our vacuum cleaners nowadays are bagless, but think of it like a large vacuum cleaner. So these are big fabric bags that trap particulate matter from combustion or industrial processes. A shaker device will knock trapped particles loose into a collection hopper below. The particulate matter is then collected and taken into a landfill. So it's still going into the environment via the landfill, but it's not going into the atmosphere. And this is kind of what a baghouse filter looks like. So back in the day, vacuum cleaners had actual like bags that you had to put in them. So that's why I reference a vacuum cleaner. But it's the same concept. Think of it like a vacuum cleaner, like you're trying to clean the floors of your house, and it's going to trap all of that dust in the vacuum itself and not allow it to, be in the atmosphere anymore. And that is that. Let me know if you have any questions.